I am doing great. This is actually one of my very favorite topics, and so also happens to be a topic that sometimes frustrate people a little bit. So I love talking about stimulus equivalence because we often I see those light bulbs go off. We say, oh, it's actually not that hard and it's actually kind of fun. It's like a riddle. So thank you, Marcia. So let's go ahead and get started. Before I get started in the chat box, thank you, Farah. I was going to ask on a scale of 1 to 5, how does everyone feel about stimulus equivalence? 1, I have no idea. It might as well be Greek to me. 5 being I'm an expert. 3 being I get it, kind of, but I get confused sometimes. Okay, so we're good. So it looks like we have a little bit of room to grow. Some people feel comfortable. I'm going to go through kind of a little bit of the history and then explain it. And then I embedded about 15 questions or so. So we'll have a lot of time to practice. So awesome. All right, so I do see some new people that I don't think have joined our free Zoom guides before, so welcome. My name is Trudy Giorgio and I work with the AB Study Guide. We are so happy to hold free Zooms for everybody and kind of build the community. So I'm really glad to meet some of you. Please feel free to friend me so we can get to know each other a little bit better. All right, so let's take it back to the beginning. Stimulus equivalence, what is it? In 1971, Murray Sidman did an influential experiment where he demonstrated the development of an equivalence class among arbitrary stimuli. So what does that mean? Stimulus equivalence refers to the observation that training a few overlapping conditional relations results in the emergence of a number of other conditional relations among the stimuli without direct training. So that's a lot of words to say, if you train a few things, you get some things for free. So if you train specific conditional relations, you may have the learner will result in the emergence of other conditional relations without that direct training. So for those of you that are teachers and behavior analysts, what's fun about this is we know we can't teach every single thing. It's not possible for us to teach every single relation, but if you strategically teach a few, then it will we'll have emerging response classes, like a BOGO. So in order to have achieved stimulus equivalence, the relation must demonstrate accurate responding to untrained or discriminated stimulus, demonstrating reflexivity, symmetry, and transitivity. So basically, you need to have all three. You need to demonstrate reflexivity, symmetry, and transitivity in order to have achieved stimulus equivalence. Okay, so a couple of fun fill-ins. First one, blank stimulus class. Stimuli that share common physical forms, such as topographical structures, or common relative relations, such as spatial arrangements, these are developed through stimulus generalization. And the second one, blank stimulus class. Oh, by the way, also, if you can type privately to me, that way we don't have reactivity. And the second one, stimulus class, blank stimulus class, stimuli that evoke the same response but do not share a common stimulus feature. Example, they don't resemble each other in physical form, nor do they share a functional relationship. They are developed using stimulus equivalence. It's okay. I know you're so excited to jump right in there, Jacqueline. I appreciate it. Okay. And also, if you don't know, just write don't know, because I'd like to give people a chance to respond, and sometimes there's a delay. It's totally fine if you just want to listen and learn. Okay, so some of you guys got it right. It's a feature stimulus class or arbitrary stimulus class. So I did put this in our Facebook group the other day, and I think I put the stimulus equivalence and stimulus generalization, and some people put stimulus generalization for both. So think about it this way: feature, topographical, generalization. So the individual develops through stimulus generalization. That's how they develop the feature stimulus class. Similar, think about it, similar in feature. Your arbitrary stimulus class is developed using stimulus equivalence. So that's what we're going to be talking about tonight. Arbitrary stimulus class. They don't resemble each other in physical form. They don't have a relational relationship, but they're developed through stimulus equivalence. All right, so your equivalence triangle, the solid arrows indicate conditional discriminations that were explicitly taught. So get used to, we'll practice, the straight line is going to be something that was taught. The dotted line or the dashed line, those are going to be the conditional discriminations that emerge without having been actually taught. Can anybody in the chat box tell me, what do I mean by conditional discriminations? And if you want to extend that to what do I mean by explicitly taught conditional relations and emerged conditional relations. Sure. So how about this? When we teach learners conditional discriminations, what are we teaching them? So when we teach conditional discriminations, we're basically teaching in the presence of a specific SD, the individual responds and they get reinforced. So when I teach you touch the cat and you touch the cat, I am teaching it's a conditional discrimination. So in this example, the explicitly taught conditional discriminations might look like CAR, the spoken word car, is equal to the picture of the car. This was a SC, a conditional discrimination that was explicitly taught. What's another, in this exact equivalence triangle, what's another explicitly taught conditional discrimination? Explicitly taught are the straight lines, and it looks like A are the spoken words, B are the pictures, and C are the text. Chelsea says KEY to the written word key. Perfect. So a lot of times you'll see a stimulus equivalence triangle with just cat, cat, and cat, right? This one happens to have 3, but that's okay. Cool. So tell me, what are some derived or untaught conditional discriminations? So the learner, these relations were emerged without being explicitly taught, but they derive that specific SD to response. Let's put it that way. Picture of the dog to written word dog. Picture of the dog to written word dog. Exactly. Perfect. Excellent. So straight line, taught, dashed line, emerge, or untaught, untrained. So the 3 parts of the stimulus equivalence are going to be the set of stimuli characterized by reflexive, symmetric, and transitive conditional relations among stimuli. That's called an equivalence class. So in this example, the equivalence class is apple to the spoken word apple to the written word apple, the text apple. So reflexivity. Can anybody tell me, just looking at the top part, what's the taught trained relation and what's the untrained relation? Just with reflexivity. Just with the, yeah, with the apple for reflexivity. And for fun, what do you call that if you were going to train this for a learner, maybe? Okay, yeah, great. So the apple is the same as the apple. That was trained. And then what was untrained or derived is going to be the apple to the apple. This is identity matching. This is when you have an array of pictures, you say match, and the learner matches the cookie to the cookie. That's your reflexivity. Our second one, identity matching, exactly. So we are looking at A equals A. What I think people get a little bit tripped up on is that they, oops, here we are, is that they look at this A equals A, and it looks like the reflexive relationship is A equals A. But what the key is here is one is taught, trained, one is untrained or derived. So this is simple, non-symbolic matching to sample. The behavior of matching the identical stimuli are under reflexive stimulus control. So if I train you this, if I train this to you and you emerge that relation, I can say this relation is under reflexive stimulus control. All right, second one is symmetry. And that occurs with reversibility of a sample stimulus and a comparison stimulus. So notice with this one, we didn't have a sample and a comparison stimulus, but here this would be the sample, this would be the comparison. This is match to sample without direct training. So if A equals B, then B equals A. So the stimulus control of A and B are said to be symmetrical. So I think of symmetrical like in the mirror. It's me, it's my physical body, and it's a picture of me. Me equals my image equals me. So can somebody tell me what is A equals B and B equals A here? What's the trained, the taught, and what's the untrained, trained and untrained relation? Yep, right. So picture of the apple equals the spoken word apple. Therefore, the spoken word apple is the same or is equivalent to the picture of the apple. Trained, untrained. Yep. Taught, derived, or emerged, the emerged relation. All right, and then our critical test for stimulus equivalence is transitivity. You need to have all three, but transitivity is the critical test. So the derived untrained relation that emerges as a product of training two or more stimulus-stimulus relations. So the A equals B, B equals A is the first stimulus-stimulus relation. The B equals C equals B relation is the second stimulus-stimulus relation. Then your A equals C relation is going to be the final critical test for stimulus equivalence. So notice with this one, we taught the apple is spoken word apple, trained. I got the spoken word apple is the picture of the apple, derived. I taught the picture of the apple is the text apple, trained. Emerge is going to be text apple to the picture of the apple. And these guys, that's our freebie, that's our transitivity. This individual learned the text, the spoken word is the same as the text is the same as the spoken word. All right, so our equivalence class is formed because all the stimuli in that set are under reflexive, symmetrical, and transitive control. They are reflexive, symmetrical, and transitive with each other. All right, so let's say that this is a picture of my dog, Ike. Ike is in everything. So let's practice. Get in the habit of not looking at just the triangle. I think what everybody tries to do is they get one of these questions, they immediately draw the triangle. But the key is going to be, this is the trained relation, this is your derived relation. So in this example, the spoken word dog is trained to match the picture of Ike. This is our first relation because then I'm sorry, let me take that back. Our first relation, somebody tell me, what would the reflexive relation look like for any of these stimuli? Okay, yeah, the spoken word dog is the same as a dog. So this would be our A equals A equals A, identity matching. So we have three demonstrations of reflexivity. Yep, same thing here, exactly, Linda. Picture of the dog equals the dog. Spoken word Ike is the same as Ike. Super. So we have our reflexivity. How many symmetrical relations do we have? We have our dog, spoken word dog is trained to be the picture of the dog, and the derived relation is going to be the basically the inverse. The derived relation is the opposite. So we have one demonstration of symmetry. Then we have our spoken word dog is the same as the word Ike, right? And then Ike, so we can also do this. sometimes I'm just going to do it in a different color. We have our A, our B, and our C stimuli. Okay. Now, people have asked me before, does it matter which one is A, B, and C? Does it matter where they're placed in the triangle? No, it doesn't. They don't even have to be in a triangle. They could be wherever. It's just easy to visualize it this way. Right? Okay, super. So we have our first, we have the A equals B to B equals A relation. Then we have the A to C and C to A relation. What happens here? Then the individual, without any formal training or direct training, derives that the spoken word Ike is the same as the dog Ike, and the opposite, B equals A. So breaking it down this way with our trained relations and our derived relations are going to be the best way for you to be able to identify what's going on here, right? Another thing that I recommend, I see people trying to like code things, write it out. If it's a spoken word, put it in a thought bubble. If it's this picture, if it's like a flashcard or something, put it on there. If it's a cup of tea, draw the cup of tea to the, you know, iced tea or whatever it is. Get specific. And we're going to go through one example, two examples that are going to drive you crazy. Draw it out. I am going to take a screenshot of this and I'll post it for anybody who is interested. You could try to explain to them what that is, that craziness is all about. Okay. So whiteboard strategy, I always have to think to myself RST because I always want to say symmetry, reflexivity, transitivity. I always have to like stop to myself. I think identity matching is symmetry. So RST, and then have a just your stimulus equivalence triangle here where you have the trained and the untrained, and you can plug your stuff right into here. Okay, so let's do one at a time here, okay? All right, so everybody have a piece of paper, pen, let's practice this together, okay? So Susanna, the BCBA, taught Simon to match the picture of the sandwich to an actual sandwich. Later, Susanna replaces the actual sandwich with the written word sandwich in the array in order to teach the student to match the picture to the written word. Which of the following would the learner have to perform independently in order to demonstrate symmetry? All right, so everybody draw it out and let me know what you think the best answer is. Match the picture, sandwich, the actual sandwich. The picture of the sandwich and actually later replaces the actual sandwich. Picture. All right, it's like another minute or two. I'm getting, people are changing their answers. So it's Simon to match the picture of the sandwich to an actual sandwich. Later, she replaces the actual sandwich with the written word. The picture to the written word. All right, so the answer, oops. Well, I gave the answer to this one, but we can work that one. So the answer is B. Can anybody tell me why? Or show me what they drew? I don't think I have a picture. All right, so I actually haven't worked at these for a while. So let's look at this one. Drew a picture to the word. Okay. So I actually haven't worked at these ones for a while. So let's see what's going on. Okay, Susanna the BCB taught Simon to match the picture of the sandwich. So here is that's a sandwich. Picture of a sandwich to an actual sandwich. Okay, so they taught her that straight line. Okay, then Susanna replaces the actual sandwich with the written word sandwich. The written word sandwich in the array in order to teach the student to match the picture to the written word. So picture to word. The direction of the arrows is important too, right? What I teach you, this equals that kind of thing. Which of the following would the learner have to independently in order to demonstrate symmetry? So symmetry equals A equals B, therefore B equals A. So of these answers, the picture of the sandwich with the sandwich, right? That would be our derived relation. Right? Those of you may have seen the answer here, the answer when I flipped to it, but okay. Number 2, Sandra was working with her speech therapist on animal identification. Her speech therapist said soup and showed her the written word soup in bold black print on an index card. She finger spelled the word soup for Sandra too. She also showed Sandra a picture of a soup or soup and told her that it was a soup. When Sandra was reading a book, she saw the word soup and said soup. What relation is Sandra demonstrating? Yeah, I gave it away. Okay. All right, so the answer here is symmetry, and let's talk about why. All right, Sandra was working with her speech therapist on animal identification, and then speech therapist took a hard left and started talking about soup. That's okay. So she said soup, so we're going to put in quotes, and showed her the written word soup. So I'm going to put in quotes or a thought or a speech bubble, whatever. I'm going to put the text in a box on an index card. She finger spelled the word soup. This is S, right? Unless I'll just make a fist. That's a fist. She finger spelled the word soup for Sandra too. She also showed Sandra a picture of soup. So sometimes you're gonna get stuff that might seem like extra information. Put it all in there too. And then, so like I said, it doesn't always have to be in a triangle. She showed Sandra a picture of soup, told her it was soup. When Sandra was reading a book, she saw the word soup. So let's do this the order. Speech therapist said soup and showed her the written word soup. So showed her this. She also finger spelled the word soup for Sandra too. I guess that would go this way, right? Because she said soup and then she fingers read it. She also showed Sandra a picture of soup and told her that it was soup. right? Then when Sandra was reading a book, she saw the word soup and said soup. So this was she that was not trained. That's our symmetrical relation. Nothing. Nothing she was learning about. It was incidental teaching, maybe, Courtney. She was like, hey, looks like let's talk about soup here. Okay, great. I'm hoping that the straight line and the dotted line help, and I'm hoping that like actually drawing it out and not trying to just kind of guess and make an A, make something a B, because in that one there was like extra information that you didn't need. All right, so match to sample procedure, the procedure when a stimulus is presented and taught to make a match a secondary stimulus, so that would be the comparison stimulus, such as the word car to a picture of the car. So you have identity matching, but then you might also have your non-identical matching, but it's still match to sample procedure. When the two stimulus are correctly matched, a reinforcer is given to increase the future likelihood of a stimulus matching to occur again. For those of you guys who came to the verbal behavior Zoom guide that we did recently, we talked about some items are not technically verbal behavior. Match to sample is one of them. We teach match to sample to some of our earlier learners because this is a really important step in teaching stimulus equivalence, and also just, you know, like equals like. All right, so different types. We have two different types of match to sample procedures. Identity match to sample, like I said earlier, I think Jacqueline said earlier, when sample and comparison stimuli are physically identical. So the yellow circle is the same as the yellow circle. Our second type is symbolic match to sample. So relationship between the sample and comparison stimuli is arbitrary or symbolic. So in this situation, I taught you that these random lines and curves, the text yellow, is the same as this. This is a conditional discrimination that I taught that is not based on any sort of formal similarity. It's symbolic or arbitrary. So one of our task list items, how's everybody feel so far? We're going to do some more practice with the stimulus equivalence questions, but before we move to generative learning or derived relations, how does everyone feel about symbolic and arbitrary classes? How does everyone feel about, you know, the RST, drawing it out, match to sample? Okay. Good. So generative learning is basically derived relations. Derived stimulus relations are a relation between two or more stimuli that is not directly trained or taught and is not based solely on the physical properties of the stimulus. So stimulus equivalence basically says this equals this. Soup equals the text soup. Dog equals the spoken word dog. Stimulus equivalence involves deriving relations of sameness or equivalence. That's stimulus equivalence, right? Relations other than equivalence can also be trained and derived. So stimuli and events can be related in many different ways. So when we look at relational frame theory, we're looking at derived relations. So this is one of the pretty cool things that you think about. So the same concept of stimulus equivalence applies, but it's just not equivalence. It's different kinds of relations. So if I taught you that X is bigger than Y, and I taught you that Z is smaller than Y, we have our two symmetric relations. X is bigger than Y, therefore Y is smaller than X. Z is smaller than Y, therefore Y is bigger than Z. And you get for free, our derived relation is going to be, nobody taught you that X is bigger than Z. Nobody taught you that Z is smaller than X, but you derived this relation. This is an emerged relation that occurs because of these two trained relations. I think it's pretty cool. So derived relational responding is the same rules, the same concepts apply, but instead of doing relations of equivalence, they're just derived relations, some sort of relational responding based upon just different kinds of relations between different stimuli. Cool, right, Ruth? So here is an example of a contemporary article. Mark Dixon and a few other people trained a few different relations. Now with this one, they had 4 relations. They had A, B, C, and D. We had the spoken country name, country location on a map, a flag, and then the continent name. So they train A to B, B to C, C to D, and then your D to A is your test relation. So it would look like I said, same principles apply really. They trained the spoken word on the country name to the country map. So they trained A to B. Oh, wait, is it country location on a map? What's the name? Okay, they trained that. Then they trained the country location on the map to the country flag. They trained that guy. Then they trained the flag to the continent name. I guess they pointed right at Italy, wherever it is, something like that. And then you're going to assume that there was also this relation, symbolic relation, metric relation. And then they got this for free. So derived relational responding it's the same thing. But imagine Dixon and a few other people have done a lot of academic, how to use derived relations to teach academics. So instead of explicitly having to teach this, like I said, they got it for free. It's pretty cool. All right. There's an article recently where they trained people how to play the piano or read music doing stimulus equivalence or derived relational responding. Okay, so why are they important? The emergence of accurate responding to untrained and non-reinforced stimulus-stimulus relations following the reinforcement of responses to some stimulus-stimulus relations. So because this suggests that not only is it efficient, but it can also engender a number of novel skills with minimal training investment. But also, this is the basics of behavior analysis of symbolic behavior and reference. So a lot of the symbolic things that we do can be said to have been derived or just emerged relations. So, all right, quick question. A derived stimulus relation is a relation between 2 or more stimuli that is not directly trained and not based solely on the physical properties of the stimuli. Not 2, directly trained, but is not based solely on the physical properties of the stimuli. 3, not directly trained, but is based solely on the physical properties of the stimuli. Or D, directly trained and is based solely on the physical properties of the stimuli. Okay, so yeah, 1, it's not trained, it's derived. And we're not looking at equivalence, we're looking at stimulus relation. So it's not based on the physical properties of the stimuli. So the map and the country, the map and the spoken word Italy are not physical. There's no physical similarity. Okay, cool. All right, so Lily is slower than Ike and Billy is faster than Ike. Who do you think would win a race? Sorry, my husband's laughing because he's Billy and those are our dogs. So who do you think would win a race between these 3 people? Who would win, Lily, Ike, or Billy? So this is going to be an example of how you're going to derive information based upon 2 relations that you were just told. Oh no. Okay, can you see it again? Sorry, I clicked out of it. Okay. So we know that Lily, here's Lily, here's Ike, and here's Billy. We know that Lily is slower than Ike. I'm just gonna do an S. And we know that Billy is faster than Ike. So if Lily is slower than Ike, then that means that Ike is faster than Lily, right? Then we also know that Ike is slower than Billy. So if Lily is slower than Ike and Billy is faster than Ike, who is going to be faster amongst this relation? He's faster and Lily is slower. Awesome. So you derive the relation that Billy is also faster than Lily and would thus win the race. Yay, Billy. Everyone says yay, Billy. So this is a derived stimulus relation because it was not directly taught and was not based solely on the physical properties of the stimuli. So yeah, if you have something like this, draw it out and then not only do the relation straight and in the way in which it was taught, the direction in which it was taught. Also, I don't know if you know, it's just like with the lines, I wrote slower or faster. So small or bigger, spicier and less spicy. You know, ghost peppers are spicier than jalapenos, whatever it is. Whatever relation was trained, just write that where the line is, and that's going to help you to decide the relations between the stimuli, the conditional discriminations. All right, this one is tricky. So write out exactly what you see. In quotes, I'm gonna make it a little bigger. Is it capital? Is it a spoken sound? Is it a textual sound? Yeah, it's a text. Okay. So Sammy was taught in class that S is the same as S. The next day, her therapist asks her during circle time, what is the same as S? Sammy replies, S. The therapist then tells Sammy that S is the same as, which of the following would demonstrate symmetry? A, Sammy saying when asked what sound the S makes. The therapist asking what letter says S, and Sammy identifies the S. Sammy chooses S when the classmate asks what letter says S, and Sammy exclaims, S must make this sound. Linda, you were fast. Wow, she's on it. All right, so C. This one, so when I worked through this one with people, what they mixed up on was the capital and the lowercase. So like I said, be very, very careful. So we have a big S is the same, I'm gonna put underline, is the same as S. The next day, so she's taught that the big S is the same as the lowercase s. The next day, her therapist asked her during circle time, what is the same as S? And Sammy replies, big S. So cool. She demonstrated what? She demonstrated, what's this? Good, reflexivity. Symmetry, sorry. S equals S would be reflexivity. I do that all the time. I'm telling you, I have to go RST in my head. The next day, her therapist asks her during circle time, what is the same as S? She says big S. Okay, then the therapist tells Sammy that the big S is the same as sound. So she taught her this, the phonetic S. Which the following would demonstrate symmetry? Sammy chooses S when a classmate says what letter says S. There you go. So and I think everybody wants to make it transitive. Everybody's like trying to fill this in because then they're like, yes, A equals C. But look at what they're asking you for. Okay, number 2. Susanna, the BCBA taught Simon to match the picture of a, did we do this one? Yeah, we did this one. We did the soup one. Okay, Saul is learning Spanish at school. He has learned that hola means hi in English. His brother then taught him that bonjour means hi in French. The next day when Saul got home, his brother said hi and Paul responded bonjour. Is this symmetry, transitivity, reflexivity, or reflexiveness?
Doesn't care.
All right, cool. So it's symmetry. Paul is learning Spanish at school. He learns that hola means hi in English. He learns this. His brother taught him that bonjour means hi in French. The next day when Paul got home, his brother said hi, and Paul responded with bonjour. So we have symmetry. Wait. No. Huh? So, hi. All right, cool. Okay, Sasha is traveling in Spain. She did not know how to speak Spanish before she arrived there. When she arrived, she's taught to say salute when someone waves to her. Then, without being taught, she starts waving to people when they say salute. What type of relation is this an example of? Yep, symmetry again. Can somebody give me an example of what a reflexive relationship would look like here? Yeah, if I taught you wave, I said, oh, like when I greet you, and then you wave back, right? Or if I taught you bonjour, oh, bonjour, and the person says bonjour, that would just be reflexivity. Salute to salute, exactly. Okay, Sally presents a picture of a spider, and Seth selects a stuffed spider from an array of toys. Sally then presents a stuffed spider, and Seth selects a picture of a spider. What type of relation is this an example of? All right, so Sally presents a picture of a spider. This is a spider. And so presents a picture of a spider, and Seth selects a stuffed spider from an array of toys. This is his stuffed spider. It's like a sun, kind of. Sally then presents a stuffed spider, and Seth selects a picture of a spider. There we go. Oh, I'm sorry. Sorry, then presents a stuffed spider and Steph selects a picture. There we go. So we have the A, basically A equals B, therefore B equals A. You guys, if it is helpful for you to put the A, B, and C on, your stimulus equivalence triangles, that's cool too. But for me, the A and the B and C are just symbolic. The actual picture or image of what it is helpful. And I had one person who was like, I can't draw. So she actually wrote stuffed spider, picture of spider, whatever it is, as long as it represents that to you. Stimulus class. Do they have the same typography? Stimulus class. It's, yeah. Okay, good question. All right. So Sarah was taught a spoken word spider is the same as a written word spider. She was also taught the written word spider was the same as a picture of a spider. Sarah being able to give the picture of the spider to the therapist when the therapist asks, give me a spider, is an example of. Another kind of tip here is the response here of selecting, labeling, pointing to, giving isn't as important as the relation amongst the stimuli. Because I've seen people people want to, oh, well, she's giving it and she's labeling it and she's pointing to it. Just look at the stimuli, the relations amongst the words picture, the word spider. Jacqueline, yes. Yes, you are definitely correct. Yeah, so I had transitivity as the example because it was that final A to C relation, however you wrote it. However, it does meet stimulus equivalence because it does check off your symmetry, reflexivity, and transitivity. So I think probably it is a transitive relationship, but because of that, it does demonstrate stimulus equivalence. So thank you for pointing that out. So transitivity is not an AKA for stimulus equivalence. Transitivity is the final check or the final criterion, and then we have established an equivalence stimulus class. All right, Sully. Okay, this is the one that is a little rough. Okay, Sully is taught that 0.50 equals a half. Half equals 50%. And 0.50 also equals 50%. The next day, the student responds half when shown 50%, indicating that both are equal. They are also taught that half is the same as 0.5 and 50% is the same as 2 times a quarter, 2 quarter in parentheses. After interviewing their notes, Solly says half must also equal 50%. What did Solly demonstrate in the previous sentence? No, Courtney, write it out exactly the way it is. And this is also, you may see questions that have more than 3 stimuli. There might be some extra kind of distractor stimuli that don't, just kind of hanging out there. So you may have something that doesn't look like a triangle. It's like a weird hexagon shape. Yeah, this one is kind of hurts your brain a little bit. But I feel like this one really does explain how real derived learning happens. You know, we have so many relations in our head of equivalence that are a lot more than just an A to B and C relation. I have an A, I have a B, and I have a C. All right, so this one, let's work through this one because this one is this one takes a minute. Okay, so Solly is taught that 0.5 equals 1/2, so straight line. Half equals 50%, and that 0.5 also equals 50%. Then the next day, the student responds half when shown 0.5. So they, when shown this, oops, they say, wait, hold on. The next day, Solly responds half when shown 50%. Okay, I almost messed up there. Half when shown 50%. So he was shown this, and he said this, okay? That looks like a transitive relation just between the three of those, right? Indicating both are equal. He's also taught that half is the same as 0.5, so half is the same as 0.5. 50% is the same as 2/4. 50% of 2/4. After reviewing the notes, Solly states that half must also equal 50%. Boom, boom, boom. This is right here, basically our A, B, and C. How many of you guys, your brain's like, yeah, this is why drawing it out exactly what it is, the arrows in the order in which it's taught. This is just like a, what do they call it, like a red herring. They just kind of threw that in there to, you know, drive. You had 5 different stimuli in this. Kara quit. No, don't quit. This is the hardest one. I'm not gonna lie. I was working on this with someone I was working with, and I kept mixing up the 0.5 and the 50. It was very, very fine conditional discrimination there. And then this came in, and I'm like, what's going on? So just be careful. Yeah, this is definitely the hardest. No, Shanna, we've worked through these before. Yes, exactly. And you want to know why? Because in our head, we derive relations so fast that we don't even realize that half equals half. We have learned 0.5 equals 50% probably in like the 3rd grade, and now we don't even discriminate between the two. The topographies are different, but they have equivalence. Transitivity is if you're looking at the trained A to B, trained A to B, you get B to A for free, right? Trained B to C gets C to B for free. Your transitive relationship is the A to C and technically also the C to A. That would make it a transitive relationship. But in this example, the derived relation one way did explain that those two stimuli that were not trained, they derived that relation. Good question, Ruth. All right, so we have two more. Let's power through these. So when I was over at Santiago's house, we were playing with his toy spinners. Yes, train derived, or you can say emerged. Shannon said is A to B train and B to A free. Yeah, if they demonstrate that. If I say half equals 0.5, and then you can tell me 0.5 equals half, that would be an emerged relation. That would be an emerged symmetric relation. All right, when I was over at Santiago's house, we were playing with his toy spinners. I handed him a red spinner and told him to put it by the other identical red spinner. Putting the red spinner he had in his hands, the other red spinner demonstrates what? And bonus, Chelsea, awesome, bonus if you tell me what that is called. Everybody rocks this one, cool. Identity matching. Yeah, you might, on the VB map, you might see it as like 3D to 3D match to sample in an array of 3 or whatever it is. Great. All right, so I then handed Santiago a picture of the red spinner and showed him to put it by the actual toy red spinner, and then handed him another red spinner that he put by the picture of the red spinner. Putting the picture to the red spinner and the red spinner to the picture demonstrated what? Shanna, which one? I'm not sure what that means. All right, cool, symmetry. So this is non-identical matching, basically, picture to 2D to 3D, 3D to 2D. So, great. All right, guys, thank you for